welcome to our second to last unit of our geometry second to last section of our geometry unit, G9. What you can do today, you can calculate missing dimensions by multiplying through by scale factor. So we talked about similar figures. That's a two-dimensional thing, similar figures. Now we're going to talk about similar solids. Solids is just a way the vocab word we use to represent three-dimensional shapes. So similar solids are three-dimensional. They have the same shape, but different size. So they're the same shape, but they're different sizes. Scale factor is the big thing today. This is what you must know. You must know this vocabulary inside and out. Scale factor is a ratio. A ratio means a fraction. A ratio of corresponding sides. So scale factors are a ratio of corresponding sides. There's a way to find missing lengths. It's just like similar figures at first. This part isn't too bad. You can bump it up now and find missing lengths by multiplying by the scale factor. That's a way you can definitely do. But I like to go back to the old school and create a proportion. I think to myself, if I already learned proportions, why not use it instead of doing a whole different strategy? So we can create a proportion or multiply through by a scale factor to find this missing value x. What I recommend let me just say all of my students today is to always use the ratio smallest to big. The smallest to the big. That is going to be your best friend when we create these scale factors. So I'm going to say smallest to biggest, smallest to big. The small side is to the big side as the small side is to the big side. And then we solve. We solve using cross product. A lot of you already know. I'm just bumping it down a little bit just to refresh our memories. Cross products are equal. 5 times x is equal to 6 times 12. Five x equals 72. So x is equal to 14.4 centimeters. That is nothing new. It's just it looks different. Same strategy, creating a proportion. I want you right now looking at this next example. It says two cylinders are similar. The small has a diameter of 4 and a height of h. The large has a diameter of 5 and a height of 11. What is the value of h? So right now what I want you to do is draw a picture and create the proportion. Compare with someone next to you. Okay, what I suggest a lot of kids do is draw a picture if you're given any word problems. Pictures are my best friends with math because I love to visually see them, okay? Two cylinders are similar. The small cylinder, so I'm going to make my little small cylinder here, has a diameter of 4 and a height of h. Hey, I feel good. I can already see diameter and height. The large cylinder has a diameter of 5 and a height of 11. What is the value of h? I like to do now, it doesn't matter, but it will matter later. I like to do smallest to big, just to get, so I can understand scale factors. I want to do that. You could do biggest to small, but with scale factors, it's best to do small to big. So I'm just going to go small. H is to what? 11. Small side is to the big side. I could have said 4 is to 5 first. It doesn't matter. As small side is to the big side. Okay? And then I go 11 times 4 divided by 5. And what do we get h to be?
8.8.
8.8 meters. Okay. Nothing too shabby. It gets shabby on the next page. Look at the next page and take a look at the little rules I have there. Okay, we utilize scale factors. Remember, scale factors is a ratio of corresponding sides. So we utilize them to find surface area and volume of similar solids, similar three-dimensional shapes. So if the scale factor of a similar solid is A over B, that's the initial scale factor, A is to B. Then the ratio of the surface areas is A squared is to B squared. And the ratio of the volumes is A cubed is to B cubed. What helped me with this? How many dimensions, if you're doing area, what dimension are you? I'm a two-dimensional thing, right? If I'm doing area, I'm squared. Area is always square. If I'm doing volume, what am I? Cubed. So that helped me realize what I needed to do with the numbers. What I always need, your need always, is your scale factor, your initial scale factor. That's always where you're going to start today with this stuff, with surface area and volume. You start with the scale factor, your initial one, A is to B. So that's our one main need. Let's apply it. The surface area of the cylindrical pitcher is about 90 square inches. The volume is about 150 cubic inches. The pitcher and creamer are similar. Find the surface area and volume. So my first need is my scale factor. So my scale factor is the ratio of corresponding sides, small to big. 3 is to 6. Small is to big. Okay? Which is 1/2. That's my initial scale factor. Now in order to apply it with surface area, I need to know what the proportion is. The ratio of surface is A squared is to B squared. So I say that my surface area scale is 1 squared is to 2 squared, or 1/4. So I always start with my initial, go figure out my surface area scale. Now I can create a proportion. I start out with what I just figured out, my initial scale factor, the surface area scale factor. And again, this is small is to big. So the surface area of the cylinder pitcher is 90. Is the pitcher the big or the small one? Big. So where does it go? And then I solve it. So 90 divided by 4 is 22.5. We are not done, right? Now I have to figure out volume. So I go back to my initial scale factor, 1/2, and my volume scale is going to equal 1 cubed over 2 cubed. Why? Just because they told me. That's what it says right here. It says the ratio of the volumes is A cubed to B cubed. That AB is your initial scale factor, which is 1/8. Now I can create a proportion. 1/8 goes first. Now this is small to big. And I say its volume is 157. It's for the cylinder or the pitcher. Is the pitcher the big or the small? The pitcher, the big. So where's 157 going? on the bottom. So 157 divided by 8 is 19.63. And that's the volume of my creamer. Okay, the next example says a box has a surface area of 54 square inches and a volume of about 27 cubic inches. The edge lengths of the box are a third of the edge length of a larger box. They already gave me, this is my initial scale factor. So this 1/3 is my scale factor. They gave it to me. My initial one, the one I go back to. Find the surface area and volume of the larger box. So the 54 and 27, is that the big box or small boxes? Small. Because it says find the big box, that means they gave me the small box. So again, we always do smallest to big. Smallest to big. Always. Just keep that in the back of your mind. And I have 1/3 as my initial scale factor. So now if I'm finding surface area, I need a surface area scale. According to my rules, my surface area scale is my initial square. So it's going to be 1 squared over 3 squared, which is 1/9. Maybe you want to just find your scale factors right away and then create proportions in the end. I'm not sure what's best for you, but my volume scale, volume, it tells me a cubit, 3-dimensional. So it would be 1 cubed is to 3 cubed, which is what? 127. Now I can create proportions on both of them. The scale is always that first fraction, the scale we figured out. And then now this is surface area. We were given a surface area of 54. Is this the small box or the big box? Small, because it says find the big. So this 54 is the small. Where does small go? Top. And then solve. Whatever that is. 54 times 9 is 486.
54 is in the top.
Yep, because it's small. Because it says find the volume of the big. So that means what they gave me was the small. Okay. Proportion here, the 1/27th is my first fraction. Volume. It says the volume is 27 inches. Is that the small box or the big box? Small, because they want to find the big. So that means they told me the small. So the volume is going to equal 27 times 27 is 729 cubic inches. Okay? Intense, right? Pretty gosh darn intense. So you don't have very much homework, but you do need to try this out.